Okay, so transforming linear functions. All right, we did points. Okay, moving them left and right, up and down, reflecting them. All right. So now we're going to look at it using lines again. All right, so we'll review this to give you a better grasp of it, hopefully. So first of all, looking at translation. So we're moving it left and right or up and down. Okay? If we're moving it left and right, a horizontal shift, okay, then that's right here. It says f of x becomes f of x minus h. In other words, when it's a horizontal shift, whatever the shift amount is, which is h, if we move it to the left, then we're going to be adding that amount to the x value. If we're moving it to the right, we're going to subtract that amount. Okay? So, but the general form is f of x minus h. Yes, this becomes a little bit tricky. If it's a vertical shift, okay, so if it's vertical, then we're going to add it to the function. Okay, so whatever your function is, it just means we're going to add whatever that amount is, like plus 5. So that means we move the line or move all the y values or all the points go up 5. Or if it says minus 3, then we're going to move it down 3 units. Okay. Then we have reflections. So horizontal reflection will be across the y-axis. In that case, the x values all change signs. So that's why it says f of negative x, because all the x values are going to change signs. All the positives are going to become negatives. Negative x's become positive. And then there's a reflection, a vertical reflection across the x-axis, which means then that the whole function is going to change signs. It means the y values are all changing signs, but the whole function is then going to become negative when we do that. Okay? So horizontally affects the x, vertically affects the y. If it's horizontally, you can notice that it's, when we say a function, we say f of x. Anything that's horizontally then is inside the parentheses with the x. So f of x minus h, or f of negative x. If it's vertical, it's outside the function. It's being done to the whole thing. Okay? Horizontal, just the x. Vertical, the whole thing. All right, so here we're going to transform the rule x minus 2, and we're going to move it 3 units to the right. And then we're going to find the new rule. Since it's moved 3 units to the right, that means it's affecting the x. So what I'm doing then is that this is going to become so my function f of x is then going to become f of x minus 3, because in this case then we'll say that the value of h is equal to 3 because it's moving it to the right. And if it's horizontal, it's f of x minus h. So we're going to move it 3 units to the right. So we say f of x minus 3. So wherever our x's are, we're going to replace them with x minus 3. So my x minus 2 then is going to become x minus 3 minus 2. Right. We replaced the x with x minus 3. So our transformed function g of x would then become x minus 5 when we simplify it. So if I take and put on here that we've gone 3 units to the right, So this point here that's at 0, -2 is going to be at 3, -2. The point here at 2, 0 is going to be at 5, 0. And then we'll have the line that goes through those points, which is the line x minus 5 because look at the y-intercept. The y-intercept is at -5 still. So if it's a horizontal, since this says 3 units to the right, it's going to be x minus 3. If it said 3 units to the left, then we would put x plus 3 in here. Okay. If it's right, it's positive. If it's left, it's negative. So you're replacing it with a, if it was to the left, we would say f of x minus a -3, because h would be -3 if we're going to the left, which when I simplify that, it would be f of x plus 3. All right, so let's look at another one here. Here we have a linear function defined in the table. Okay, right here. They want us to do a reflection across the x-axis. So we've got the points -2, 0, 0, 1, and 2, 2. And they want a reflection across the x-axis, which is horizontal or vertical? If I go across the x-axis, is that horizontal or vertical? The x-axis is this one right here, right? So if I go across the x-axis, I'm going vertically, because I'm going to go from a point here to a point down here. So that would be a vertical reflection. Okay? So a vertical reflection means then we're going to take f of x, our function, and our reflection is going to be negative f of x. As we're doing vertical reflection, which would be this one right here, reflection across the x-axis, vertical. So you can do two different ways. Okay? You can find the function, then transform it, or you could transform the points and then find the new function. It would actually be up to you. Okay? I would rather, in this case, since I know it's linear, I would rather transform the points first and then find the new function. So these were the current points I'm working with, -2, 0, 0, 1, 2, 2. So we're going to end up with new y values, right? Because if I'm reflecting it across the x-axis, is the x value going to change? No, it's not. Okay, the x value stays the same. The y value is going to change. Okay? So I'm going to have new y values. Okay? What's the opposite of 0? 0. Okay? What's the opposite of -1? Or of 1? -1. And the opposite of 2 is -2. Okay? So all we've done is we've taken them and we've changed the y values. So we'll say g of x equals. So we need to find the y-intercept and the slope. Okay. The y-intercept is when what equals 0? When x equals 0. So when x equals 0, y in this case is -1. So our y-intercept is -1. And what's our slope then? Change in y over change in x. So m is -2 minus -1. So -2 minus -1 over 2 minus 0. So -2 plus 1 is -1. Half would be our slope then. So that would be our equation of our line. G of x equals -1/2 x minus 1. Now, that would be the second method. Transform the points, then find the function. If we use the first method, find the function and then transform it. Well, the function here then, with the original points, the y-intercept is positive 1. So f of x would have been positive 1, and the slope was 1/2. So the original function would have been 1/2 x plus 1. And if we're doing a transformation is to do the negative of that function, that means that g of x would equal the negative of that. And so if I distribute this negative sign here, we would get the function that we found doing method 2. So you can do it either way. Totally up to you. Okay, I want you to do both of these. Okay, so letter A says the translation of 2 units to the right. That means we're going to take f of x, and it's going to become f of x minus 2. Because in this case, h is equal to 2 because we moved it to the right. So that means h is plus 2. If we moved it up, then we would say k was plus 2. So that means I'm just going to replace x with x minus 2. So instead of having 3x plus 1, I then have 3 times x minus 2 plus 1. We replaced the x with x minus 2. So this is 3x minus 6 plus 1, or 3x minus 5 would be our g of x. And in this case, much easier to do it this way. I mean, actually, it's up to you. If you wanted to graph the line, and then move your points over 2 units, and then find the new equation, then you can do it that way also. If that helps you, then do it. Whichever way is easier for you. Okay. All right, letter B. Reflection across the x-axis. So once again, we're making the y's the opposite. So we have -1, -2, and -3 here. So g of x would equal, our y-intercept is -2. And our slope in this case, as y goes down by 1, right? Okay, x is going up by 1, so that would just make it -x minus 2. Yes, 40. Where the graph crosses the y-axis. Where the graph crosses the y-axis. That's the y-intercept. When x is 0. Okay? All right. Now, stretches and compressions are actually probably the hardest part of it because of what happens with them. Horizontally, when I do a horizontal stretch or compression, we're actually doing a reciprocal. Okay? Here's the thing. When it's horizontal, it works the opposite of the numbers they use. When it's vertical, it does exactly what's happening. So if it says it's shifting it up or down, then we say plus whatever for up and minus for down. But if it's horizontal, we would say plus for going to the left and minus for going to the right. When it's stretches and compressions, let's talk vertically first. So if we're looking at vertical stretches, then all I do is multiply the function by, or wall the y values by whatever I'm stretching it or compressing it by. Now, when we do that with the x values, if I stretch it horizontally or compress it horizontally, when I do that to the x values, it actually creates the reciprocal in the process. So whatever my value of b is, what I'm using here for b, then I'm going to do inside the parentheses and horizontally, it would be 1 over b times x, or the reciprocal. All right, so let's look at the example here. Okay? So let g of x be a horizontal compression of f of x equals negative x plus 4 by a factor of 1/2. Write the new rule for g of x and graph the function. Okay, so we need a graph here. So let's get that in here. Okay, so here's the line. Come on. Doesn't like me. There we go. Okay, there's a line y equals x plus 4. All right? And it says we're going to compress it by a factor of 1/2 horizontally. Okay? So that means we're going to take all the x values and we're going to make them 1/2 of what they are. Okay? Because we're compressing it 1/2. So this means then, since it's horizontally, it means the value of b is 1/2. Okay? So if I'm doing a compression, so I'm going to take this function and my transformation then is going to be the reciprocal of this. So what's the reciprocal of 1/2? 2/1. Okay? So my transformation then is going to become f of 2x. Okay? And we'll see how this works in this case. So let's do it to the points first. Okay? So my x-intercept is the point 4, 0. Okay, the x value is 4. What's half of 4? 2. So I'd have the point 2, 0. Okay? Here I have the point 2, 2, right? Okay. What's half of 2? 1. So we would have this point here then, the point 1, 2. Okay. Here I have the x values, it's at 0, 4, right? What's half of 0? 0. Oh, look at that. Did that change the y-intercept? No, because if I multiply or divide by 0, or if I multiply by 0, what do I get? 0. So if I do a horizontal compression or stretch, the y-intercept does not change because when I multiply by 0 for the x value, I'm still going to get 0. So here's my new line. Okay? So let's see what happens. So if I do my transformation, I had negative x plus 4 was my f of x. So my transformation is going to be the opposite of 2x plus 4. All I did is replace x with 2x. And so this gives me a g of x equals negative 2x. Oops. Negative 2x plus 4. That's my new function. Okay. Well, let's check that and see if it's right. The y-intercept is still 4, right? Okay, so we have the plus 4. Well, let's check our slope now. So if I go, so I'm going to go down 4 and over 2 for my slope. Down 4, that means it's negative, right? So negative 4 over 2 for the slope, which is negative 2. So by doing that compression, I changed my slope is now doubled, right? So it did the opposite, okay? Instead of multiplying by 1/2, I ended up doubling the slope. Okay? But my y-intercept stayed the same. So if it's horizontal, it changes in the parenthesis using the reciprocal. Okay? If it's vertical, then you just multiply the function by it. So if this said that we were going to do a vertical compression by 1/2, then we would just multiply the whole function, negative x plus 4, multiply that whole thing by 1/2, which means that the y values would only be half as much in that case then. So instead of my y-intercept being 4, my y-intercept ended up becoming 2. All right, so let's do this one. So which letter are we dealing with? Since it's a stretch or compression, is it A or B? Okay, it's vertical, so that means it's A. So that means that A is equal to 1/4. So that means that f of x is going to become transformed into 1/4 times f of x. That means we're going to multiply this whole function by 1/4. Okay, so let's think about that. Let's physically see it first. Okay, so here we have the line y equals 3x plus 2. So I have a y-intercept of 2, and the slope is 3, right? So we go up 3 and over 1. And so we get this line right here, right? So if I'm going to compress by a factor of 1/4, okay, well, that means it's the y values that I'm changing. Well, I have a y-intercept of 2. What's 1/4 of 2? 1/2. So my y-intercept is now going to be down here at 1/2. Okay. So let's think of, let's see, the other one we have here is at 5/1, or at 1/5. And let's see, well, what's 1/4 of 5? 1.25, right? 5/4. Okay, right? 5 times 1/4 would be 5/4. So that means it would be, I don't know if it'll put it in here or not. Nope, it won't. I'll do that. So it would be approximately right here. Right? So we would have this line here then, close to that line there. Okay. Now, to find the slope then, it's a little bit tougher to find the slope in this case because we don't have two good points. So we're going to have to just take our 1/4 then. So we went with 3x plus 2, and we transform that. It's going to be 1/4 times 3x plus 2, because we're multiplying the whole function by 1/4. So then g of x would be 3/4 x plus 1/2. Okay. The whole thing is, so this means that my slope is 3/4. Okay, so if we had a slope of 3/4, from this point here at 1/2, we'd go up 1, 2, 3, and over 1, 2, 3, 4. So we have a point. Oops, I need to get rid of my drawing. Go up 3 over 4. And then if I draw that line, oh, not that line. I know what it did. I'll do that. Okay. So if I draw that line then, doesn't like me now. So then that line there would be pretty close. The slope is 1/2, is going to be 3/4, so it's going to be not as steep as the previous one. All right. Okay, putting them together. So where we got to do more than one. Okay, so this is very important, using the letters to be able to do this. Combining transformations. So we're going to take g of x, and it says it's a horizontal shift of f of x equals 3x. We're going to the left 6 units, followed by a horizontal stretch by a factor of 4. And then find the new rule. Okay. So we're going to start with f of x equals 3x. and we're going to go to the left 6 units. So is that A, B, H, or K? Okay. If I'm going to the left, is that horizontal or vertical? Okay, that's horizontal. Okay, so that means it's going to be H. Okay, so in this case, then H is equal to, because we're going to the left, H is negative 6. So that means we're going to take f of x and we're going to transform it to become f of x minus negative 6, or what? Plus 6. So we're going to replace x with x plus 6. Okay? Since it was going to the left, that means h is negative 6. So we're going to get 3x is going to become 3 times x plus 6, or 3x plus 18. So identify what it is, A, B, H, or K, or if we're doing reflections. Then it says, followed by a horizontal stretch by a factor of 4. So we do the first thing, shift it to the left 6. She's what? Out in the hallway?
Oh, thank you, Lord. Just jump over.
Now we're going to perform the horizontal stretch by a factor of 4. So is that going to be A, B, H, or K?
H.
So horizontal stretch. Okay, so you should, if you have your book open, where is it talking about horizontal and stretch? Which letter is that? It's B. Okay, so this means that B is going to be equal to 4. Okay? And what did we say about if it's a horizontal stretch or compression? We're doing the reciprocal. Okay, so we'll call this h of x here because they want us to get g for our answer. So we'll use h there. So we're going to say we're going to take h of x and we're going to transform it by doing a horizontal compression of 4. Since b is 4, that means it's the reciprocal, so it's going to be h of 1/4 x. Okay? All right? So b is 4, so it's 1 over the value of b, which is the reciprocal of 4 would be 1/4. So then that means we're going to take 3x plus 18, and it's going to become 3 times 1/4 x plus 18, because we're not changing the y-intercept now. Okay? Horizontal stretch or compression does not change the y-intercept. So g of x then will be 3/4 x plus 18. Move one step at a time to do them. Do the first one and then the second one. Right? But if you write it out, if you use the symbols here, what I did here and here, all right, identify the value you're talking about. Here it was H, here it was B, okay? Identify them and then plug them in, okay? Try that, and hopefully it will help you and make it a little bit easier than the first time around when you try these.